Hello, it's Mr. Colati, and today we're going to be going through our second section of electricity, which is current, or electric current. Electric current is just like current in a river. It's how fast something's flowing. So when we talk about current in a river, we talk about how fast the water is flowing. When we talk about electric current, we talk about the flow of electricity. Make sure you read through the slides, especially where you look at how we draw circuits and the conventional versus electron flow, the way we draw the circuit. We have a formula that relates current to charge again, which is the charge over time. Let's do this question. While starting a car, the 12-volt battery supplies 1,230 coulombs of charge for 2.89 seconds. What is the current? So 12 volts, well, that's the potential difference. Remember, we talked about that yesterday, or last section. I like to think of potential difference as that's the amount of money you've given to each electron. So they have a lot of money to spend. Coulomb, that's the number of charges, or the number of electrons you could think. Oh, sorry, that's Q. That's our charge. 1,230 coulombs. And the time is 2.89 seconds. And what are we interested in? Current. Well, we have a formula for current. This is charge over delta T. So 1230 over 2.89. 1230 divided by 2.89. That gives me 425.6. 425.6 amps. And we should put that into two significant figures, so 4.3 times 10 to the 2 amps. So amps is the unit of measure for current. Remember, current is the flow of electricity. And there's some important things in the some important understanding ideas in the presentation. One is that current's the real killer, the real dangerous thing about electricity. When you walk across a carpet on a winter day and you get electrocuted when you touch a door handle, that's a very high voltage. That's like 5,000 volts that goes through your finger, but it's a very small current. On the other hand, if you look at this graph here, 0.1 amps is enough to kill a person. So current is very, very dangerous, and high current is very dangerous. So a lot of the circuits in our house and a lot of the safety devices for electricity are related to minimizing current, because if you have too high a current, things start to melt or burn, and so we have a lot of safety equipment in our house. So you can read a little bit about that. Once again, current is about the flow of electricity. So if I go to my analogy, current would be how many charges are passing me at any one particular moment on my river analogy. Or if you want to think about my money analogy, if each of these electrons has $50 to spend or has some sort of voltage to spend, current is how many electrons there are passing by, how many customers there are passing by. I hope that helps. Good luck with your homework problems, and until next time.